Can everyone see the screen?
Yeah.
Yeah. Okay, cool. So I'll be discussing pathological functional equations today. So what are pathological FEs first of all? Uh, Functional equations, as we know, are just like FEs. So functional equations, what are some of the solutions you generally get as which F satisfies? Like you get F is identically zero, or like f of x is equal to x for all x, or you might get f of x equal to x squared, or something like that. I mean, let's say 1 by x, 1 by x squared, whatever. So these are the solutions we generally get as a solution to functional equations. But like since they're functions, they can satisfy like literally anything. For example, if you know the Cauchy's equation, so f of x plus y equal to f of x plus f of y. Over years, this has like extremely pathological solutions. What does that mean? It's just like very arbitrary to characterize. So there may or may not exist a closed form, but it's not as nice as this, like as nice as the functions above. So when we say it's like pathological when some of the solutions are like they are not a very nice form which we generally observe. Uh, we generally don't get this many times, but I mean most of the functional equations we have are the good ones, but pathological FAs are interesting. Like many times you might get these where the answers are the solution of function is pathological. Okay, so let's start with some examples. Is everything clear right now? Does anyone have any doubts?
Yeah, there's no doubt.
Yeah, okay, cool. At any time, if anyone is like not following or having any questions, you can just like interrupt. Um, so a thing is, I have some like only 3, 4 problems today. So if we like complete those before time, we will try some new problems. So first problem is f is defined from integers to integers, and f of x plus y whole square. Okay, does everyone get the problem? Basically, it is find all f. I mean, that's the law. Find all f from z to z is that for all x comma y belonging to z. Is the question clear?
Yes.
Okay, I'll give you guys some time to try. If anyone has any ideas or like if someone can guess solutions or has any ideas regarding solutions, feel free to share. I'll give you some time to try.
f of x is equal to root x first.
It's like z to z, right? So root x does not have for all x.
All right, sorry.
So like you can just put x equals to y equals to 0 and you will get f of 0 is equal to 0 or 2. So you will get one condition is that f of y square is equal to f of y whole square is equal to f of y square or f of y whole square is equal to f of y square plus 2. So
Yes, that
these
is
are
right. I'll start writing. So sorry. So I'll call this condition as like p of x comma y. So as we said, by substituting
p
standard
of
p of
0.
0 comma 0, you get f of 0 is equal to 0 or 2. So I'll just make cases. So case 1, f of 0 equal to 0. What would you like me to do?
So you will just put f of p of x y, p of 0 y, then you will get f of y whole square is equal to f of y.
Is equal to f of y ka whole square. Yeah.
After this, you can just try substitution values. Like if you get f of 1 is also equal to 0 or f of 1 is equal to 1. So I think you will get one solution is that f of x is equal to 0 for all x.
Yeah, that is a solution obviously. I'll write I'll just try to guess of solution sets. All right. Can I make some space here? How to make some space? Yeah, okay. So some solution sets we are guessing are f is identically 0 is the solution, and we'll see if there are more solutions. I'll just create some space here. Yeah, okay. So you said that you substitute, I think in this you substitute 0, comma 1 basically. That would give you f of 1 equal to 0 or 1. Okay, for this feels pretty strong. Can you like just maybe try to just finish something from here?
Sir, may I suggest?
Yeah, sure.
We could substitute x plus y is equal to 0.
Okay. Yeah, so you mean you want p of x comma minus x, right?
Yes, p of x comma minus x. Right.
So you get what? F of x square equal to 0 for all x.
Exactly. Yes, sir.
Yes. Also, like, don't call me sir. I will
Sorry.
just call. No, it's fine.
Actually, we can
Uh,
solve the second case also that way, I guess. No,
Sorry.
no, we can't. We can't. My
So
mistake.
you get this thing. Any idea how you would like to proceed?
In the second case, we do the same thing, I guess. We would just substitute x and minus x because we know the value of f of 0, right? So we get
In
that
which case you want to say? Okay. Let's try to first finish this case first. Okay. Would that be fine?
okay, okay.
So can anyone just finish this case?
F of x
I just
whole
yeah.
square is equal to f of x square is equal to 0, right? So f of x is equal to 0 for all integers.
Yeah, yeah, sure. F of x whole square equal to f of x square is equal to 0. Therefore, f of x equal to 0 for all x belonging to z. So we get our first solution set, which is f identically 0. Okay, let's move on to case 2. F of 0 equal to 2. Yes, so as you were saying, we start with p of x from minus x, right?
Yes.
Yeah, so p of x from minus x, we will get that f of x square is equal to 2, I think.
2.
No, well, yeah, f of x square equal to 2 for all x belonging to z. Okay, yeah. Can someone try to characterize or guess what sort of solutions are we expecting in this case?
So you get f of y whole square is equal to f of y square plus 2. So you get f of y square is equal to 2 for all. So you get f of y whole square is equal to 4.
Yeah.
So yeah, so you get f of y whole square equals to 4. If you have f of y is equal to 2 for all that, I guess.
No, no, this is like plus minus 2, right?
Plus minus 2 is.
Yeah. So can you like I mean, how should I say? Can you like to characterize for all for which y it should be plus, for which y should be minus, for which y it doesn't matter, or something like that? Because this is an option, so you will get something like for for this set S1 it should be plus, S2 it should be minus, and S3 it is anything plus or minus.
Is it like the point-wise trap or something?
Yes, exactly. Because this doesn't mean that f is like plus 2 for all or minus 2 for all, right? You just get f of y is plus minus 2, so you can get the point was. Also, wait, is there anything in the chat? For some reason, I'm not able to see the chat. I'll stop share and share again. It's been a minute. Okay, yeah, we're good. Okay, so can someone try to guess what are the S1, S2, S3? I mean, some of them may also be empty, like you might get that this can never occur or something, but try to characterize.
We could substitute the expression back into the original one, like f of x plus y whole square is equal to 4. F of x plus y
Okay,
square is
so you want me to substitute here, right? So f of x
4. Yes,
plus y
square,
square is equal to 4. Yeah,
which is equal to f of x square plus f of y square.
yes, that is correct.
So clearly it cannot be minus 2 for any value.
Or any square you mean, right?
Oh, yeah, yeah, right.
Yeah, I think we have that here, right? We have that f of x
Yeah,
square equal to 2 for all x.
okay, okay. So then we could make the sum in such a way that it is a square.
I'm sorry.
No, that won't work. Sorry, my bad.
Okay, let's try to see what we have right now. So we have that f of x square is equal to 2 for all x belonging to z. And so since we know what already squares are, let's just like this not include squares. So f of y is equal to plus or minus 2 for all y. I mean, I'll just write down for right now, not a perfect square. So for each of these y, you can assign plus or minus. I mean, it is either plus or minus. So does there exist any more restriction on this, or is this like very free?
I actually think there is no restriction
Yeah, that is correct. So if you just see, uh, because
because f
f
of x
of
plus y whole f of x plus y square will always equal 4, and that can happen anytime.
yes, exactly. So you have this thing. By this thing, you will always have that this is equal to 4, and this is either plus 2 or minus 2. We don't care because anyway the square will be equal to 4. So the solution set that we get is, I'll write it above where we were writing. Yeah, so why is like, let's set S be equal to x square where x belonging to z. Then uh, so and define G arbitrarily.
Explain
So
what is
and
the smaller, great smaller sign. Is it Z?
sorry,
The sign, yeah, this one.
yeah, that is right. Sorry for the very bad handwriting. So we get at f of x equal to 2 for x belonging to S, and f of x equal to 2 times g of x for x does not belong to x. Is this clear?
Would this be the
Anyone else?
only way to write the solution?
Sorry.
Would this be the only way to write the solution?
I mean, this is one way. You can just like say define g arbitrary to plus 2 as minus 2 and write only g of x here.
Yeah, makes sense.
Okay. Anyone has any questions regarding proof or anything, any part which I should repeat?
So like what was the pathological thing?
Oh, okay. So pathological thing was this because you generally don't have that define g arbitrarily from this to this, right? So for all x not belonging to S, I mean, so this part, you don't have anything fixed. You can like you have a high chance of freedom here. Like you can either do plus or minus, right? It's not a closed form.
Oh,
Did you get? I mean, pathological is a very what do you call subjective word. So uh, I mean, I feel it's subjective. It might have a real definition. I am not really sure. Okay, so should we move on to the next problem? Okay, so this was us from N to M. This is sort of an anti-condition, GCD of f of x, comma f of x plus y is equal to GCD of x comma y. So, okay, so the structure of this question is a bit different. So, f belonging to n is said to be, it is said to be Canadian because this is a Canadian problem. If it satisfies this. So, question is find all m such that f of m is equal to m for all Canadian functions. Okay, is the problem clear?
Yes.
Okay, cool.
Canadian function could
Sorry, I didn't catch you. Can you please repeat?
x is equals to x. That is everything. We get GCD, get that LHS is of x comma x plus y.
Your voice is cracking. I'm not able to get exactly what you're saying.
Can you
Can you try writing on chat? Oh, like is there anything in the chat? Because for some reason Zoom chat is glitching at my end. I'm not able to see the chat.
No, there's nothing in the chat.
Yeah, okay, cool. Okay, I'll give you some time to try this. Yes, f of x equal to x is an obvious Canadian function. That is correct. So yeah, so but yeah, that is correct. But there may exist some other. So you get it for that Canadian function f of x equal to x for all x. But there may exist some other Canadian functions for which this is not the case, right?
yeah.
Okay, I will write an equivalent reformulation here. So it might help to try the problem. I mean, it's like just the same thing. So whatever it is that above, and just the condition is replaced like. Okay, can everyone see why this is equivalent?
Yes.
Yeah. Okay. Cool. I'll give you some. I'll give you like 5 10 minutes to try.
Wait, very sorry, I didn't understand where did the x disappear suddenly.
Oh, okay. So we wrote this thing as y here. So basically, this x plus y just became this condition x less than y, and GCD of and this you can also write this as GCD of x comma x plus y, right?
Yeah. Oh, okay, okay, okay.
So we just reformulated it.
for composite y divides f of y.
Okay, so what you're trying to say is for composite y divides f of y.
Not
Are
all
you sure
composite.
are you sure for composite is the only condition? I think you require something a bit stronger.
Yeah, you need two prime factors dividing. I think
Yes,
if
exactly. Okay.
it's not a power of a prime, that should be the condition.
Yeah, that is correct. Okay, there is something in the chat. Why is x less than y? X less than y is the condition because this is x and x plus y, right? And this is natural to natural, so you can't take x to be negative or y to be negative, something. Y to be negative. So you require x less than y. And so p of 1 comma y, f of 1 is copend of y. Yeah, okay, that is the interesting observation. It's a correct observation. I just don't see how it might help. I'm not sure. I'll write it down. So observation one is that p of 1 comma y. And then as I just said, we get that. Okay, I'll give some more time to try for others. So what Ajit has claimed is if y is not equal to, sorry, if y is not equal to p to the k for prime p and like k belonging to whatever, I mean, z greater or equal to 0 also, then y divides, uh, sorry, y divides f of y. So this is one of the claim. I'll give others some more time to try, so like 540 or something. You can try the claim or you can try the problem, whatever you want.
like we got f of 1 is equal to f of 1, comma f of y is equal to 1, the GCD. So like if f of 1 is 1, then we can't get any information out of this, right?
Yeah, that is true. I mean, that's why is a good observation that I don't see how it is useful. I'll rewrite this better. I'll write it as like very bad. So we have that P of how will I write this? Yeah. Okay, let's wait for 2 minutes, or then we will start like trying to prove this claim.
Sir, I have an idea. Sorry, I have an idea,
Yeah, it's fine. Go on.
which might force f of x is equal to x for composite. Sorry, not composite, not power of a prime x and y.
Yeah, okay. I think you're on the right track. For like just to make sure that we won't have to say that every time, I just like write let s is equal to like
Not power of a prime.
yeah, not power of, I mean s is power of prime,
Okay. Yeah.
so z minus s is not power. Okay, so you can like try to complete your solution, and then we'll prove claim one. Okay, anyone else has any ideas regarding claim one?
I mean, I was thinking of putting p of y comma f of y, but I was trying to check if f of y is greater than y.
Yeah, if you get this, then you can put that, right? Because if you get this, you will have f of y is greater than equal to y.
Yeah, so I was trying to like assume, like take a case that f of y is greater than y and try proceeding.
Yeah. That is a good approach. I think that would be similar to what Archus is doing. If I think I know what he's doing, I mean whatever.
Yes.
Okay, so yeah, so
I
let's
think we can prove this like by using x divides f of x.
um, can you like tell how?
Yeah, like we have x divides f of x, and then
Yeah,
like if we consider largest prime divisor of like y with its power thing pt, then and put x as pt, then pt divides f of x, and it should also divide f of y.
yeah. So you don't really require this here, right? You just require the other thing.
Yeah.
Yeah. So we'll write this later. We'll need this later. I'll write it that time. So as Hardik said, we can like do this. What did I do? Okay. So what we can do is we let so y does not belong into S. So y is equal to p1 to the alpha 1, p2 to the alpha 2 pt to the alpha t, where like t is greater than or equal to 2. So we have that for all I. So So as we said, we substitute P of Pi to the alpha I comma y, and that would imply that since the RHS is just GCD, which is Pi to the alpha I, we get Pi to the alpha I divides f of y. And since this ranges over all I, and these are like co-prime, you will get that y divides f of y. Artist, was this your solution? Or did you have anything else in mind? Or anyone has any other solutions?
I have a slightly different one maybe.
Okay, sure, go on.
I assume x is equal. I assume that GCD of x comma y is equal to d,
D, okay,
and x is equal to dx1, and y is equal to dy1.
yeah.
So, like no other relatively prime factor can divide y1. So y1 is 1.
Y1 is 1. What, sorry, I did not get how. What is X here exactly?
X and y are the variables over there in the original equation.
Okay, so you substitute D, and what do you want about Y1 and X1? So you will have the DCD of X1 and Y1 is 1, right?
Okay, okay. I don't think. Yeah. Yes, we will have the GCD of x1 and y1 is 1. And
Hmm.
moreover, we already know that x divides f of x and y divides f of y. So we already know ki the GCD of
Wait,
f
wait,
of
wait. Sorry to interrupt. Are you suggesting a proof to the above claim or a continuation after the claim?
continuing to the claim.
Okay, okay. Sorry, I was asking you if you had a proof to the claim.
Acha, oh,
Okay,
then
let's
I
just
also have
make
a
clear if.
different one.
Sorry.
I also have a different one then.
Okay, sure. Can you like tell that? We'll just complete with the claim with everyone and then we'll continue after that.
Sorry.
No, no, it's fine. Just if you have a different proof there, you can tell.
Yeah.
What is all this?
So let p and q be two prime factors of y.
Yeah.
So then we consider x is equal to y by p and x is equal to y by q.
X is equal to y by q.
Yeah, two separate ones. Like first we consider y by p, then
Acha, acha, okay.
afterward we consider x is equal to y by q.
Yeah, okay, and then you do the same thing. I mean, it's like similar only. It's like same in the sense.
Maybe the variables were very different, so I thought,
It's fine, it's fine. So you just
yeah,
take, you get that y by p divides f of y and y by q divides f of y, right?
exactly. We get that all the prime factors except p divides the y, and then through q we also get that p divides y. So it's a full proof.
Yeah, also like if you do it this way, you will have to also do a VP argument because you will get that y by p divides f of y. So you will get that all primes other than p divide y, divide f of y. But you also get that since we like let r be any other prime. So you have that VR of this is equal to VR of y, and this is less than equal to, and this is equal to. So you get that VR of y is less than equal to VR of f of y.
Yeah.
Right. You will have to do this argument.
Yes. Right.
Yeah. Cool. So is everyone okay with this claim, the proof, or is there anything, any part which I should repeat? Okay, I'll take it as a yes and move on. Okay, so as someone was saying, we now can, so we want to show that f of y is equal to y for all y not belonging to S. What is wrong with this? Uh, Okay, yes, that makes sense actually. You don't need to do the VP argument because yeah, you have that LCM of y by p by what am I writing? So, is equal to y. Yes, that makes like perfect sense. So you don't need to do the VP argument. Okay. Oh, am I still audible? There was a there's a power cut at my house, so we might face some
You are
issues.
able.
Okay, thank you. So what we do is okay. So now we want to show that f of y is equal to y for all y not belonging to S. So as someone was saying, we assume that since y divides f of y, let's assume that y is strictly less than f of y. So can, can we get something?
We can put P of y comma f of y.
You want to put p of y comma. Yes, that's correct. So what you will get is GCD of f of y comma f of y, no, f of y only is equal to y comma f of y. So this is just f of y that is equal to, and since y divides f of y, this is equal to y.
Y.
But yes, so but you observe that uh, f of y,
Yeah, f of y divides f of y, if I'm not wrong.
yeah. So since this is true, you have that y greater or equal f of y is greater or equal y for all y not belonging to S. This implies f of y equal to y. Does that make sense?
Yes.
Yes.
Okay. So what we have is that f of y is y for all y not belonging to S for all Canadian functions S. Okay, so now it's just the finish. So as I mean, it's like predictable that this won't hold for prime powers. So can anyone try to construct a function uh, so, such that f of let's say p to the k is not equal to p to the k?
So now we'll attempt to prove this claim that f of p to the power k not equal to 0 k.
I mean, not exactly for so it's like there exists Canadian function f.
Okay, we
Such
want to
that
design or construct such a function.
yeah, such that f of p to the k. Also, it's like before that, it's like for all k belonging for all p and k. What am I writing? Sorry.
Okay, got it. Yes.
Yeah, I'll just write it for the sake of completeness. Okay, I've never done this for very sorry. I mean, it's like I don't know. We'll have to come up with something. Okay, this works, I think. I mean, for if you have this, you just like take one p to the dot 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 p to the k plus one. Just like swap this. I think this works. I'm not sure. Does
Wait,
this
so
work?
we're just taking f of p to the power k to be like p to the power k plus 1.
Yeah, and f of p to the k plus one to p to the k.
Okay.
So uh, f of x equal to x, or all x not equal to p to the k comma p to the k plus one, and you define this comma, and you define f of p to the k equal to p to the k plus one, and f of p to the k plus one equal to p to the k. I'm guessing this works. Let's just check if this works. Okay, what do we want for f of x? Okay, so if x and y, none of these are powers of p, we are like done. If none of these are like p to the k or p to the k plus one, we are done. So
We would have to substitute in y to make it like to ensure that it works.
yeah, because even in x, f of that thing is
Ah,
still the same.
so it's done that way. Just the y thing.
But what if y is less than that?
No, no, we have this condition x less than. We had that in the problem. I just told that. So you see, the original problem was this thing. When we reformulated, we require this x to be less than x plus one.
Yeah. Okay. Oh, okay. Oh, okay, I see.
Yeah. So font size has considerably increased over that period of time. Okay, so let's just check once if this works. So one, if your y is p to the k, so that thing has to be less than p to the k. It to be p to the k plus one.
But wait, so we don't need to consider the case when y is less than p to the power k?
Okay, wait, this. Sorry.
We don't need to consider that case when y is less than p to the power k? Why?
Oh no, I'm like saying if y is p to the k, we don't need to consider the case where. No, wait, what did I say? Okay, I said something wrong. My bad. So if y is p to the k, then x has to be like less than y, so x has to be less than p to the k. So p to the k plus one cannot divide x. So it's just GCD of p. So yeah, so you just get that x comma p to the k is equal to x comma p to the k plus one. That is like fine because
Okay,
x is
okay,
less
I
than
see,
p.
I see. Yeah, got it.
So
So just
this,
we need to check the x comma y p to the power k p to the power k plus 1. That's all that we have to do.
yeah, so now like if y is p to the k plus one, I'm checking that.
Wouldn't there be a contradiction?
How?
If
Sorry.
we assume x is equal to p to the power k plus 2,
Yeah,
and then
y is equal to.
p to the power k plus 1.
You want x less than one.
Yeah, yeah, yeah. Right, right. It's done then, I guess.
Yeah, I mean, it should be just. I just don't see. Like y equal to p to the k plus one. I think it's just case that this should work.
Yeah, we'll have to consider multiple cases.
Yeah, I mean there must be some easier solution also. I mean, or
Wait,
this
why
is
do we
this
need to consider multiple cases?
like
Like,
x is the power of p or x is less than y, something like that. I don't know. Okay, maybe we don't. Um, we have that VP of since x is y is equal to y, x is less than y implies VP of x is at most, what do you have?
k.
P to the k. So you have that VP of x at most to the k. So GCD of x. So f of x is x. Okay, it's not enough.
By cases, I meant the other prime factors of x, but that is
I don't think you'll have to like deal with that because anyway, you only care about is P. Okay, yeah,
I
yeah.
meant while
Also,
writing
it's
the
like,
solution.
sorry.
I meant while writing the solution.
No, because like you don't care about other elements because since this is P to the K or P to the K plus one, GCD will always be some power of P. Also, like this is just easy to finish. If x comma P to the K, that becomes, I mean, f of x. So if x is equal, so f of x is equal to x for all the primes less than that. So this is just equal to x comma P to the K plus one. Since you have this thing. Yeah, okay, so this works. Does anyone has any question? Is the proof clear to everyone?
I didn't get it the after the p to the power k plus one. Like, how do you handle that last step?
Okay. Which part?
The VP, yeah, the VP.
Okay, so you have P to the K plus one is equal to y, right?
Yeah.
So x less than y, and so VP of x is less than equal to, oh sorry, this is K.
Okay.
Because like x is because the smallest number with VP K plus one is P to the K plus one, but x less than y.
Yeah,
Is
sure.
this clear? Yeah.
Yes, yes.
So you have that f also for all x. So this is f of x. Sorry for the very bad handwriting. I just rewrite this. So GCD of f of x comma p to the k should be equal to x comma p to the k plus one, right? I mean, we want this to happen. So this is just x comma p to the k because f is an involution, and this is just that thing, and this holds since because of this.
Okay. Yes.
Yeah. Okay. So we are done with this. Okay, let's move on to the next question. I'll pause for a minute if anyone has any questions.
X and y were defined to be natural numbers, right?
Yeah, f was defined from natural.
Okay, then it's done.
Yeah. Okay, I have to search for a question for a minute. Give me a minute. Okay, I have like two more problems, but one of them is like pretty long, so I'll probably put it in the problem set. Let's do another question. Let's say if you are if the time is if you are left with some time to this, we can try that. Otherwise, I'll put it in the problem set. Okay. So again, f is defined from naturals to naturals. For all n belonging to naturals, you have that. So I'll just directly write it as p of n, the statement. You have that f of dot dot f of n is equal to n squared by f of n. And you take this f of n number of times. So question is, okay, I'll route this. I will like write f to the k of n as f iterated k times. So p of n is just f to the f of n into f of n is equal to n squared. So the question is, sorry, find all possible values that f of 2010 can take.
One is 2010.
Sorry?
One is 2010.
Yes, of course. So is the question clear? I'll just write this here. F and from masters to nationals. This holds, find all possible values. Yeah. I'll give you 5 minutes to try. Okay, can you say anything about f of 1 or f of solution to k equal to 1?
F of 1 is 1.
Yeah, how
f
would you
of
show
f
that?
of 2 is 2.
Yeah, like can you try to show that? Like any of the claims made right now? Can someone try to show that? I mean, or them, can you try to show that? So we got two claims right now. Claim f of 2 is equal to 2 and claim f of 1, sorry, f of 1 equal to 1. Yeah, can the person who said try to prove that?
So when n is 1, we get f of 1 into f of 1 is 1. And because the function is defined by the naturals, both of them must be 1.
Yeah, that is correct. So P of yeah, actually that is true. So P of 1 you get it as f to the f of 1 into f of 1 is equal to 1. So you have that f of 1 is equal to 1 and f to the f of 1 is equal to 1. So how do you proceed from here? This is 1.
Now you can just like replace. So like f of 1 like will be, so if f of 1 is like greater than 3, then it'll become like f of 1 minus 2 of f of 1.
Yeah, sure. So, but how does that help you?
So I thought we would like reduce it. Okay, wait, does that work?
You can reduce it. That is okay. But like, what will you do if so basically if you observe here, if f of 1 is odd, then you can just like by this you get f to the f of 1 minus 1 of 1 is equal to 1. This implies f of 1 equal to 1.
Yeah,
What
if
happens?
f1 is odd. If it's even, we have to.
Yeah. So let's say f of 1 equal to 2k or something.
What about p of f1?
Exactly. So we consider p of f of 1. So p of 2k basically
On
here.
p of 2k, yeah.
Yeah. So what you have is p of 2k. What do you have? So this implies that f of 2k equal to 1. So you have f of 2k into f of 2k is equal to 2k whole square. So this is equal to 1, this is 2k. So 2k equal to 2k whole square is obviously an entire solution. Contradiction. Did that make sense?
Yes.
Yeah, cool. So we got that f of 1 equal to 1. Also, can you try to show that there is no other element which can map to 1? I mean, it's basically the same proof. Let's just do it. So if you have f of k equal to 1, then p of k implies p of k implies like so f to the f of k. So this is basically 1 because it remains in the loop after that. Into f of k is also 1. So you get 1 into 1 is equal to k square. This implies k equal to 1. Did that make sense?
Yeah.
Yeah, so you have that f of 1 is equal to 1 if and f of k equal to 1 if and only if k equal to 1. Cool. Okay, let's move ahead. So can you try to show um how do I say? Okay, uh okay, claim another claim is okay. I think I'm rushing through this a bit, but since the time is like we're a bit low on time, I'll just like give the claim and like maybe we can try to prove it. So claim is like f is injective Can someone try to prove this? So basically, if we have f of a equal to f of b, then a is equal to b.
If we have f of a is equal to f of b, then f k of like f to the power of k of a is equal to the f to the power of, it holds for all such like repeated iterations in general. So it works even for, even if you put f of a at the top, or even if you put 2 at the top.
Yes, that is correct. So by this is equal to a square, and
Yes.
p of b is like the same thing basically, is equal to b square.
So a square
But
is b
say,
square.
yeah, because these two are like equal, so you get a square equal to b square, a is equal to b.
Yeah.
Yeah. So f is injective. Okay, so what do you propose we do next? We should like we showed f for one, we showed f is injective. Now like what could be the next stepping stone?
I'm thinking of induction because like everything is in terms of n.
Yes, induction on n or induction on what? Induction is correct. I used induction. I'm not sure about n. Okay, does induction on n work? I'm not really sure if induction on n would work because like considering the solution set,
F of n,
like sorry,
f of n induction.
I'm not really sure what you mean to say induction on f of n.
Like f of n equal to n. And
Yeah,
when
yeah,
we
but
show f of n plus 1 is n.
are you sure this would hold? Like, are you sure you can show f of 2 equal to 2? I don't think you can show f of 2 equal to 2. I mean, I know you can't show f of 2 equal to 2 because I know the solution, but like,
What if we take n to be prime? Like then they would be divisors, f of n and
yes,
the other one.
that is correct. So,
That will force
so
them to be p each because we can't have one.
yeah, exactly. That is correct. So you have that for, I mean, this is the claim for all p. When I write p, it's basically prime. Greater than equal to 3, f of p equal to p, sorry. Yeah. So you get p of p, that f square of p into f to the fp of p is equal to p squared. Now, since someone pointed out, none of these can be 1, so you will get that f square of p is equal to f to the f of p is equal to p if f of p is odd. We are done. If f of p equal to 2k, then obviously we take p of 2k. So what we have is, what do you have? Wait, this is Um, okay, square of 2 to the k is like 2k into oh, wait, what? Wait, this is also get right? Yeah, okay, sorry, I placed 4k square. So p equal to 2k is like nonsense. Nonsense. So we get that f of p equal to p. Does that make sense? Did that make sense? Hello, am I audible? Okay, yes, cool. Okay, also like there is a solution. I mean, this is actually my solution. So what you do after this, you do the same thing for p to the k, and then you induct on number of like something like number of prime factors or sum of exponents or something to show that f of odd is equal to that same number, whatever. But she's like that. So Tanishka mentioned induction. I think I now get the proof using induction. So do you want me to complete this proof or should we try the induction proof? The induction proof is like much easier, I think.
Yeah, let's try.
Yeah, okay. So okay, is the outline of this proof clear to everyone? What I said this year?
Can you go over the even part?
Okay, sure. So if f of p equal to 2k, so you also have that f of 2k equal to p, right? Since f of p equal to p due to this.
Yeah,
So p of 2k, you get that. So this 2k is basically f of 2k, and this is basically f to the f of 2k of 2k. Since f of 2k is equal to p, this is odd. This is odd. So this f of 2k turns out to be like f of 2k, and that is equal to p. Did you get that?
yeah, thanks.
Yeah. Okay. So I'll just go through this outline of the proof again. So you get f of p equal to p. So now you show that f of p to the k equal to p to the k by induction on k, of course. Induct on k. Then you like induct on prime number of prime factors or like the sum of exponents, something like that, to show that f is identity on odd. So basically, by this you will get that f of 2k plus 1 equal to 2k plus 1. Uh, okay, so you will get this eventually by this. I can guarantee that. So like induction proof, I think is much easier. So we just induct on odds. So like induct on k to show f of uh, f of 2k minus 1 is equal to 2k minus 1. So k equal to 1 case, we are like basically done because f of 1 equal to 1. So assume for k, whatever. So assume for some k, or like assume for some k minus 1 or something. So you will get that p of 2k minus 1 gives you f to the f of 2k minus 1 of 2k minus 1 into f of um, this is f of 2k. No, wait, what can I write? Sorry. Is equal to 2k minus 1 whole square Okay, so somehow we should be able to force, like this is 2k minus 1 whole square. So we want both of these factors to be equal to 2k minus 1, and then we can repeat the previous argument. So since both of these are not 2k minus 1, then one of these has to be greater than 2k minus 1, other has to be less than 2k minus 1. Oh, this is minus 1, my bad. So how do you do this? Okay, if this is, let's say f square of 2k minus 1 is less. Also note that both of these have to be odd, because since this is odd, none of these can be even. So assume that f square of 2k minus 1 is less than 2k minus 1. So let's say k dash or something. So you get that f of 2k minus 1 is equal to 2k dash minus 1, where k dash is less than k. Oh, but that is like, oh, yeah. So this is not possible since, oh, yeah, we are, I think we're done. So, I mean, we can do the general thing. So it's like, if you have that f to the, so you will get that f to the I of 2k minus 1 is equal to 2k dash minus 1 for some I greater or equal 1. So I is either f of 2k minus 1 or I is either 2 and k dash less than k. So by induction, you know that 2k dash minus 1, by induction, you know that f of 2k dash minus 1 is equal to 2k dash minus 1. So you get that f to the I minus 1 of 2k minus 1 is equal to 2k dash minus. Why am I taking 2k? Sorry, what is this? Is equal to 2k dash minus 1. And so what you can do is like just go on reducing, you will get f of 2k minus 1 equal to 2k dash minus 1, 2k minus 1 equal to 2k dash minus 1, k equal to k dash contribution. So you get that f of 2k minus 1 is equal to 2k minus, I mean f square of 2k minus 1 is equal to f to the f of 2k minus 1 of 2k minus 1 is equal to 2k minus 1. And now just repeat the previous argument. Okay, if f to the k minus 1 is odd, then we are done. If it's even, you take p of that even and get a contradiction. So you will get that f of 2k minus 1 is equal to 2k minus 1 for all k belonging to set or n, whatever. Or did that make sense? I think this induction proof is not simple. Okay, I went over this like pretty fast. So if do you want to repeat any part?
Yeah, can you go over it again?
Yeah, sure. So basically, we want to induct on odds to show that 2k minus 1 is basically odd. So we want to induct on odds we want to show that f is identity on odds. So f of 1 equal to 1, we already showed that. So assume till like, so it's basically strong induction. So we have 1, 3, 5, dot, 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 2k minus 3, 2k minus 1, and then you have 2k plus 1, 2k plus 3, dot, dot, dot. So it holds for these things, and we want to show that it holds for this thing. So we take p of 2k minus 1. We get these two terms, right? This and this. So this is of the form AB equal to Z square or like C square or something. So you either have A equal to B equal to C, or one of A comma B is less than C. Is that correct?
Yeah.
Yeah. So you assume that also none of these can be odd. 2k minus 1 is odd, so its square is odd. So none of these factors can be even. So both of these must be odd. So either this is less than 2k minus 1 or this is less than 2k minus 1. So you will get that f to the I. I is like 2k f of 2k minus 1 or I is 2, whatever. I mean, whichever is less than 2k minus 1. is equal to 2k dash minus 1 for some I greater equal 1 and k dash less than 3. This is just another odd number which is smaller than 2k minus 1. Does that make sense? So you will get this. But by induction, we know that f of 2k dash minus 1 is 2k dash minus 1. And by above thing, we know that f of how do I write it? f of I minus 1 of 2k minus 1 is equal to 2k dash minus 1. So the inner terms must be same. So you get that this is equal to this. Does that make sense?
Yeah.
And you just like go on repeating this argument and just reducing this exponent. You will get f of 2k minus 1 equal to 2k dash minus 1. So 2k minus 1 equal to 2k dash minus 1. This is a contradiction because this was like strictly smaller than 2k minus 1. What is this? Did that make sense?
Yeah.
Yeah. And the finishing argument is the same part. I mean, you just like whatever we did earlier. So you get that f of 2k minus 1 is equal to 2k minus 1 for all k belonging to rational. So f of 2010 can never be odd by injectivity. And as a matter of fact, you can like just construct a function such that it can take any even value. I mean, now since like you don't have anything to proceed or something, you can just like try to guess this. So since we are like short on time, I think we are already like done or something. I just like tell what function you can take. It's like not very hard. So you take f of n equal to n if n is not equal to 2010 or 2k. F of 2k equal to 2010. Sorry, 2010. What is this? And f of 2010 is equal to 2k. So we just need to check that this function works. So clearly p of n works if n is not equal to 2010 or 2k because it's just like identity there. For 2010, you will get that since f square of 2010 is equal to 2010. This implies f to the 2k of 2010 is equal to 2010, and so that just means f of 2010 of 2010. And basically the same thing works for 2k also. So p of 2010 and p of 2k also hold. So we have that f of 2010 can take any even value. Did that make sense?
Yes.
Yes.
Yeah, okay, cool. So okay, I have like one or two more I have like one more problem, but I'll put that in the preset. Okay, if I maybe I'll give it right now because I don't have that many problems to make a preset. I'll just like write it down, and if I later get enough problems, I will compile them into a preset. You can try this later. Let me fetch the problem. Yeah, okay. Is it from Andrew? Yeah. I'll just continue. F is defined from naturals to naturals such that for all n belonging to this is just like find all functions here. For all n naturals, f of n whole square is equal to n into f of n. Yeah, that's the problem. If I get enough problems, I will compile into a preset. Otherwise, you can try this problem.
But which preset?
Sorry, which preset?
Where will it be shared?
Oh,
It's
it will
like
be
an
shared on.
assignment.
Are you there? Wait, I'll just stop share. Wait, I'll just get back to you. If does anyone have any doubts? Otherwise, we can stop the recording. Okay, I think we can stop.